Ja. Hi, goedenavond allemaal. Welkom bij wat alweer de 20e editie van Ode aan de code is. 20 keer dat we het organiseren, elke avond dat we Ode aan de code doen, lekker kennis delen over een onderwerp wat wij als DIJ interessant vinden. En omdat we zijn de laatste paar maanden bezig om een AWS gecertificeerde club te worden. Dat betekent dat we dus ook een aantal sprekers over leuke AWS-technieken die wij zelf interessant vinden hebben gevraagd om hun verhaal te komen vertellen. Een van die technieken is AWS Amplify. Ik ben zelf met een aantal collega's bij de afgelopen Web Summit in Lissabon geweest. Heel veel al over gehoord, super interessant. En onze eerste spreker, Léon Rodenburg, die weet daar veel meer van dan ik, gelukkig. En gaat ons vertellen wat je daar allemaal mee kunt en hoe vet dit is. Dus ik zou zeggen, Léon, the stage is yours.
Dankjewel. Oké. I'm gonna ask the first question if I should do this in English or Dutch. For me, it doesn't matter. I'll start in English, and if no one says that they want to continue in English, I'll just keep on going. So let's get started. So for today, I'm gonna explain to you what AWS Amplify is and what we can actually achieve by using AWS Amplify. So Amplify is a framework provided by AWS, of course, and it helps you to build a serverless application in a matter of, I would say, hours, maybe within a day. And we'll see that you could even go faster than that and get something up and running within an hour, maybe, or even within this talk. So let's get started. First, a little bit about myself. I work at CBA as a software development consultant, which means that I help companies implement software stacks across like both front-end, backend, mostly in the cloud. And I can either help them do it, so I can help them implement, or I help other people implement it by coaching them or by joining a team or by training people. So I have a pretty diverse job, which I like. And I've been doing that for around 3 years now at Xebia. I'm also an AWS certified solutions architect. So I took all the solutions architect exams, and I've been working with AWS for, I think, 2.5 years, 3 years as well. So right since I started at Xebia. AWS has been sort of like the go-to cloud for me whenever I help people in Europe deploy their applications. But I also have a background in Chinese linguistics. So I've lived in China for some time. And when I help Chinese companies implement software stacks, which I also do, I always use Alibaba Cloud, which is a Chinese cloud offering. And they're actually the biggest in China. So I've also been selected as an Alibaba Cloud MVP, which is like a copy of the Microsoft Azure program in which they select people that sort of help the community around their product. And I'm the organizer of the Alibaba Cloud meetup in Amsterdam. So I tend to focus on these two clouds whenever I build anything. Mainly European customers will go on AWS. Chinese customers might want to look at Alibaba Cloud. So if you have any questions about that, you can also ask me. Another thing that started, I think, about a year ago is that I'm brewing beer. So I actually pretty like it. So it's a sort of, for me, it's like a really, it's a cool hobby to actually spend some time crafting something, just like with software, only then you can drink it. So it's also a good match for the vrijdagmiddagborrel, whenever you have drinks on Friday. So I've had some successes. I've also had some minor issues, but I think everyone that brews knows what these issues are. And I've been trying to scale up my brewery a little bit. If there's anything you would like to discuss afterwards, you can just send me an email. My email address is right there. Or you can connect me on LinkedIn, or you can find me on GitHub. And the things I'm going to show you today are also on GitHub, and I'll share the repository link with you afterwards. So right before we get started, I actually want to start with a demo. So I was thinking of shuffling things around. So instead of going doing all the theory first, I would like to show the power of Amplify first. So what I'm going to do is I'm going to deploy an application. Let's say that we need it to be scalable. We need a lot of people to use it concurrently. We need people to log in, so it's safe. And yeah, because it's serverless, we don't want to do any maintenance. So we just want to deploy it. We want to run it. We want to host it under a custom domain name with like an SSL certificate. So it's all secure. And if at all possible, they would like to have it online within the hour. So if that's the kind of requirements that you're hearing, then you know that you're going to have to use, or you're going to have to use Amplify or a product like Amplify. So I want to start out with the demo. For that, I have my terminal here, Amplify, and I'm going to explain everything afterwards, right? So I'm just going to show you in like high speed what you can do with this. Then hopefully your mind will be blown, and then I'll explain what the hell just happened. So Amplify as a CLI, and I'm going to deploy a React app because I'm kind of a React guy. So I'm going to create a React app in this directory, and I call it DIJ demo. So this is going to run for a bit, and this will scaffold like a simple React application in that directory. It will install almost the whole internet because you need a lot of libraries for doing React these days. And when that's done, I can start connecting it to Amplify. So just waiting a little bit. Needs to install some more things. And I'm just really starting out. So I'm starting out fresh. And you could follow along for this, but it would mean that you have to have Amplify installed. Okay, apparently it's going to do a commit. So I need to fill in something. Sure. Okay, so there it is. So we can go into the directory. We can call yarn start, or you can use npm, whatever your preference. And then once it's built, we should get the demo application. Like this is what you run locally whenever you start out developing. This is fun, right? Well, it's nice to have locally, but actually you want to host it somewhere. So I'll start with Amplify and also the Amplify hosting. So what I'm going to do is I'm going to run in this directory Amplify init, which like sets up my project for applying Amplify. I just accept all the defaults. I use Visual Studio Code. It's a JavaScript application. It's React, source, build. Yep. So now Amplify does a few things. Yes, I want to use a profile. I use my Xebia profile. And now it's initializing my project in the cloud, which means that certain Amplify resources are going to be created in my account. You can see them scrolling past here. So it's going to create an S3 bucket, an IAM role, a few of them. And basically the whole Amplify framework is wrapped around CloudFormation. So it uses CloudFormation under the hood to actually deploy these in my account. And Amplify is a nice wrapper around that. So while we're waiting for that, I actually, oh, it's already done. Okay, so then I can do an Amplify add hosting. It's going to ask me what I want to do. I'll use the Amplify console. And I'll explain what that means later. I'll choose manual deployment. And then we do Amplify publish. So again, this is going to run for a while. In the meantime, I'll go to AWS so you can see what happens. And this is a long password. Yeah, and non-root link. Okay. Yeah, so my app is already showing up in the console, and this is because I started publishing. And so what I just got is the full hosting for my front end, and it's actually setting it up now. So it's creating the stacks, but what this is going to do is actually take my application, run a pipeline for it, build my code, and host it under the Amplify domain. So I'm going to get a CloudFront stack, a CDN endpoint, which I can reach, which will serve out my front-end application, which is already, well, relatively easy to get started. It's best practice to do it like this. So you host it in a bucket and you put CloudFront in front, and that's actually what's happening now. It also runs my pipeline for the build. I specified which step it needs. It just takes the defaults because it knows the application is React, and then often it's just an npm run build, which it does. And now it's actually deploying those artifacts. And you can follow this as well in the console. So let's see if it's already set up. Not yet. Here it comes. Okay, so now I've actually hosted my application online, and you can verify that by browsing to this. And this is on the web, like this is online. If you get this URL at the top, you'll be at it. Next thing we need is a custom domain name, so that's also easy. I'll just click in the console. I'll click add domain. I happen to have the AWS developertraining.com domain. Configure it, and then we say that everything points to to the dev environment which I created. Okay, while that is running, we can continue locally. So we now have a front end, we hosted it, that's fun, but we need to store data for this application. And we want to store the data securely, so people have to actually log into the application to be able to use it. Amplify has a thing for that. It's called Amplify Add API, which means I need to store data and I want an API. Out of the box, you can select two options, GraphQL or REST. And because it's cool, I'm going to select GraphQL. I'll give it a name. And then I'll say I want the Amazon Cognito user pool as the authorization type, which means that you're going to use Cognito to store the user data, and you get a really tight integration with the front end, the back end, and if the login of like in the front end was successful, that token can also be used to do backend calls, which is of course what you want. I'll just select everything as a default, username. Yes, I'm done. So now I'm still done. No. Yes, we'd like to store to-dos. Sounds about right. Want to edit? No, not yet. Okay. So our source code, if we check it out, there are a few things were added. So we have an Amplify directory in our source code now, which was added by Amplify. And we have a backend directory with a GraphQL schema in it. So this is the schema of the data that we're going to store. And the fun thing is that you don't have to do anything but Amplify push. Yes. Yes. JavaScript. Yes. Yes. Do fine. Okay. And then it's crunching some numbers again. What it's now actually doing is provisioning that API based on how I configured it using CloudFormation stacks. So it's just a basic setup of a backend, everything you need for that, some Lambda functions, and all these resources that you would need for setting this up manually, you'll get created for you automatically. Also, let's see if it already generated the code. Not yet. We can check how our domain setup is progressing. See if, not sure if it's up already. Nope, not yet. So we still have to wait for that until it provisioned the certificates. And while we're at it, I'm gonna add some code to our source to add, like, implement the features that we need. First off, I want to, by default, this model, like the annotation you see here, the model is not protected, but we want to protect it with our Cognito user pool. And this sounds really complicated, but in Amplify, it's actually really easy. I'm going to cheat a little bit because I have it here, so I'll copy it over. And what you see is that I created some rules over here in this auth annotation, which means that AppSync in this case, which we'll talk about later, is going to apply certain rules whenever you access this endpoint of the API. Okay, so that's that. Next up is one big change, and that's actually of our app.js. So this is our basic app component, and I have an updated one, which is based on the getting started guide of Amplify. I also have this code in a repository that I'll share, but we can walk through it shortly. So what it does is use a few hooks to fetch data from the API, and it also sets up subscriptions, which are a GraphQL thing, and it works over WebSocket, so you'll get an automated WebSocket that can communicate in two ways. So like the server to you and the other way around. And whenever someone adds data, it will also show up for the other people. So you get that real timeliness, you get that for free. There's a simple form here, and there's login. I'm not going to go through all the code. We'll see parts of it later, but this should be enough. And this is creating lots of resources. So if you look at what's scrolling past, you can see, sort of get a grasp of what it's doing. So it created a Cognito identity pool. We have some Lambda functions. We see a GraphQL API, that's AppSync. And it's sort of like, it's going to take maybe 1 more minute to actually deploy this. And then we need another update and see what happens. Domain name is actually taking pretty long today. Normally this is also done within a minute or 20. Still running. Almost there, I think. Oh, it's actually now creating DynamoDB tables, because that's where our data in the end is going to be stored. So we need those tables to store the data. It's going to create a table for to-dos, which was like the model that we saw. So we define the model here. You could add any fields you need and then update it. And then Amplify will do the rest for you, which is pretty neat. It's going to set up some data sources, resolvers. Let's see how fast it goes. Is it done? Not yet. Is this done? Not yet. Okay. I'm not sweating yet. Let's hope it finishes soon. In the meantime, we could have a look at some more of the code. So if you're familiar with React, this is going to be relatively easy. If you're not familiar with React, it might look a little more complex. So the use effect hooks that are called here are actually what you would like previously do with component did mount or other lifecycle methods on your React component class. But with hooks, it's going to get easier to actually use a function component to do all these. And what we do here is, for example, we create a subscription on the GraphQL operation, which is called onCreateToDo, which got created for us by Amplify. So we see our GraphQL files that have been generated here contain a lot of GraphQL queries for getting to-dos and listing to-dos. And they're all called to-dos because that was what I specified in my GraphQL schema. The subscriptions are there, so this is all generated for you. Don't have to worry about it. It's done. So now we have our endpoint. And the last thing is we probably need to publish again. Let me make sure that I saved all of these. Oop. I need to install a few libraries, of course. Yarn, AWS Amplify, and I think it was this one. Probably going to be AWS Amplify. Okay, we can test this locally to be sure that everything works. See if it comes up. Yeah. That was the wrong screen to refresh. Okay, so this was a screen that I wanted to refresh, and it's now showing a login form, which I pasted in from that app component. But the neat thing is that if we actually publish this now, it's going to do another build. And in the meantime, we can also see the domain. Okay, it's probably active. Yeah, still the old app. So this is now under awsdevelopertraining.com. You can go to it yourself and check it out. It should be online. And while we wait for this build, it's a bigger application now because I added a few components here and there. Let's see what happens. Okay, so it got created. How big is the bundle? Pretty big. So we're 22 minutes into the talk, and when this is done, I actually completed a full application with login, real-time data, and hosting, and a custom domain in just under 25 minutes, which is exactly what I was trying to achieve and to show you what Amplify can do. Okay, the deployment is complete. So let's see what happens. Yeah, so I have a sign up form here, or sign in form. And if you don't have an account, and nobody has an account because it's an empty cognito pool, but we can create an account. So let's try it. I'll do an easy password. I'll add my email address because you're going to get an email verification code. So you need to have that email address like in place. We don't need SMS, but I'll click this. Authentication error, which is not what we want to see. Now maybe we need to run Amplify push again. Okay. Says no changes. We have the AWS exports. And there is a cognito pool. Okay. There goes the demo effect. So I'm guessing I'm not going to make it. And or we can try to add this still, see what happens. Okay. Don't see anything weird here. Anything Apple.js, something weird? I'm guessing not. I might have to update the index.js as well. That's probably it. Got this. So we have an AWS exports file now, which contains a lot of config, and we need to configure Amplify to actually use it, which I didn't do. So that makes sense. Something failed here. So I'm not going to make the 25 minutes, I'm afraid. But I'll hope to make it within the next 5. Let me check the config here. Yeah. Okay. Probably we cannot publish now because it's broken. No. Yes. Let's test this locally in the meantime. Yeah, that's better. No error, so probably that worked. It's deploying the artifacts. I'll start here then. So I'll create the account. Simple password. Create account. Okay. So then I need to check my email because I got an email with a confirmation code. Yeah, confirmation code 319700. Confirm. Okay, so I'm in the app now. This is local, but because I'm using a single user pool, I should also be able to log in on the actual website now. So if we refresh AWS developer training, and I log in with my user details, you can see that I'm now logged in. So it actually works. Phew. So now we can create some to-dos, buy groceries and some beer. Create to-do. And this was now created, but created by unknown. Interesting. And we can see that the login is actually, or the real-time data is at least working. And voila, it works. Yeah, it doesn't work completely because I don't see your name, and it should actually show your name. But probably I can fix that real quick, because whenever I get a to-do, I'm not getting back the owner. So that's the last change then. So we change these because we need the owner field. Let's do a push again. And I'll keep it at no, but we do want to publish the front end. Okay, did I now completely break it? Yes, I broke it. Okay, why? Curious to see. GraphQL. Source. Root owner is undefined. It's not undefined. Okay, I'll keep it at this. So it doesn't work at this moment, but I want to continue because half an hour has passed. So I've used up all my minutes of actually developing, but I hope you get the idea of how fast you could go. I'm still, if I have time left, I'm going to try to fix this because I want to see it work. But for now, I'll continue with my slides. So this was a demo of what you can do with Amplify. And if it would all work, then you would have a real-time synchronization of data for multiple users. And you would have a login all working for you in a serverless stack that you don't actually have to manage yourself, which can scale up to hundreds of thousands of users. So, and the best of it is that it's free. So this whole stack and the deployment, I have to pay for the domain name, of course, but the rest is all free. So you have to hit like a very big load to actually start paying for this. So this was a really high speed demo of what Amplify could do. Probably nobody or some of you that have used it know what happened. People that have never used it before are like, wait, what the hell was this? So this was Amplify, and I'm now going to explain what you actually saw. So I use Amplify to set up this application, and Amplify is just a collection of tools on top of AWS services like CloudFront, S3 for storage, and AppSync. And together they combine that into sort of like a toolkit or like a best practices list that you can help to actually implement software, web applications, but also mobile applications. By using Amplify, you're actually adhering to a lot of the best practices that AWS set forward, which means that you have a secure API, the hosting is scalable, and you'll know that you're only paying for what you're actually using, which is like the most important feature of serverless, in my opinion. It allows you to develop and deploy rapidly. You can be up and running really quickly. So I just showed, unfortunately, I couldn't do it all the way, but I named this talk within a day, and probably I'll have this fixed in a few more minutes, which means that I will be up and running within the hour, actually. And in essence, I already mentioned this, but AWS Amplify is just a fancy wrapper around CloudFormation. So CloudFormation is an infrastructure as code tool that AWS has, and it allows you to write out, like in a declaration, how you want your resources to be provisioned. And then CloudFormation will actually look at what you have and where you want to be, and it will decide on what it needs to do to actually get you there. So that's CloudFormation. And Amplify heavily uses CloudFormation for the heavy lifting. So what I just built looks like this. So this is an architecture diagram of the application that I built just now. And there's actually 3 parts to it, which sort of like you could sort of see when you followed me through the terminal. So we have part 1, which is a front end. In this case, it was a React front end that I hosted on S3 using CloudFront. And you could also see everything happening in the Amplify console, which is, it used to be really separate from the Amplify CLI, but nowadays the Amplify console and the Amplify CLI have better integration. So you at least can work with both at the same time, which previously that wasn't the case, which was really confusing to a lot of people. The second part that we have is authentication. So whenever our front end is served, you're served a login page, and you actually need to log in or sign up. And we do that using Cognito, which is a hosted service of Amazon that will help you to build user pools and give people access to your application. That Cognito user pool can also be tied into our backend. And we use the GraphQL API, which was provided by AppSync. So AppSync, and I'll go into more details later, is a backend as a service. And because of its nice integration with Cognito or other third-party identity providers, it's really easy to get started and have your application secured. AppSync stored all its data in DynamoDB, which you also saw created in the output logs when I ran Amplify push. It created DynamoDB tables automatically based on that GraphQL model that I defined. So if I would add an entity, it would just be added to like DynamoDB as well. Then a table would get created. Getting started with Amplify is really easy. So I skipped some of these steps because I already did them. So like installing the CLI and then configuring it, I already had that configured locally. But if you want to get started, this is what you would actually need. So you would install the Amplify CLI, configure it for your credentials, and then you can start. And the general workflow is that you first run Amplify init, which just starts a project. And then you can Amplify add certain categories. And we'll see these categories later. And then you run Amplify push or publish. And for push, it will create cloud resources, like it will update your API, or it will update DynamoDB, or it will update your Cognito user pool. And for publish, it will do that as well and build a new version of your front end that it will host in the environment that you created. You can work with multiple environments. So if you have a dev, QA, and prod environment, you can separate these out. And then that way you can make sure that you first test something in development before you push it on to production or wherever you need it to be. So the hosting, and that is a category. So you can do Amplify add hosting, and it will ask you a question, how you want to host your application. And there are two choices. One is more classical, and the other one is the new integration with the Amplify console. And you see them specified here both in the lower right corner. The top one is using the Amplify console. So what actually happens is that your code is uploaded to a bucket, and Amplify console will take that code, run a build for it, and then deploy that to an S3 bucket with CloudFront in front. And the traditional way is that you just build your code locally and upload it to S3, which also is fronted by a CloudFront distribution, which is a CDN. So that will make your application available around the world and make it relatively fast everywhere. The fun thing about the Amplify console is that it adds quite some features to this whole tool set. So I often choose the Amplify console as the way of publishing, because like you saw, I could just click through like a small wizard to get a domain name up and running for my application, and also bind it to a specific environment of my application. So if I have multiple branches, you could create a subdomain per branch, and every branch is built automatically because you can also tie it in with GitHub or GitLab. And then whenever someone pushes a merge request, Amplify can build the whole application and roll it out, and you can test the front end on a subdomain before you actually merge the merge request, which is a pretty cool feature. So it integrates with React, Vue, and Angular, and like the most popular front-end libraries, and it will just deduce what it needs to do to get your app built and get it into the cloud and upload it to S3 and how to configure everything. So it's really easy to start, and you don't have to bother with it. The only thing you have to do is run Amplify publish, which means just push out my changes, and then everything will be running. So that was the first part, that was the front end. The second part is authentication. So we're going to look at that. For this, you can do Amplify add auth, which means add some authentication to my app. And there are multiple sets supported. But most of the times when you start out with a new application, you're probably going to use Cognito user pools because it's just an easy way for you to get started with setting up users for your application. You'll get a pool. People can register. You can see what users registered and if their email was confirmed, etc. It's all there. And it's easily integrated using the AWS SDKs and also the JavaScript libraries that they have. So you saw me use the UI React library, and it's in essence just a set of React components that are already configured to work with Cognito. So that's pretty neat. If you set that up, so let's say you add the auth to your application, you add the Cognito user pool, actually adding a login like form and a sign out button and everything like that is nothing more than this. So this is what I pasted in from the other place. But there's just a higher order component that you wrap your app component in. And this means that everything that's within that will either be shown if a person is logged in, and if they're not logged in, they'll see a login form, which they will have to fill in before they get access. If you want people to sign out, you don't have to design your own button. You can, of course, but you don't have to, because there's an Amplify sign out button, which you can just use. And whenever someone clicks that, they'll be redirected back to the login form. So it's really fast to start with authenticating your app. So then the third one is actually the backend API. And I've created a GraphQL API, which will link to Cognito to make sure that every call that's done to it is actually authenticated, and people are only allowed to delete their own data, for example. And AppSync is first the API. It actually has two setups. I prefer the AppSync setup, and I'll talk about AppSync then in the next slide. but you also have the choice of using REST APIs with Amplify, which is like a simple API gateway and Lambdas. So I've built those APIs as well, where you provision your own API gateway and provision your own Lambdas that are called whenever someone hits a certain endpoint on your API gateway. But it's a lot of work to actually manage. So it's a lot of work to set up. It's a lot of work to make sure everything is connected in a good fashion. So Amplify at least helps you to do it. But if you want the full power of Amplify, I would always suggest you to start out with the GraphQL API. One, because GraphQL is good. Like it's a good tool for front ends to actually specify what data they need without returning everything. And it's pretty scalable as well. So yeah, if you have a new project and you want to get up and running ASAP, then I would suggest you to work with that. The APIs are, like I said, can be secured. So they can be secured by using Cognito, but they can also be secured by, for example, Auth0 or Okta or any other like identity provider you have. And it's just a basic setup of specifying a certain like configuration keys for your third-party provider, and then they will use JSON Web Tokens to actually connect your check if the person that's actually connecting to your API has a valid token based on the JSON Web keys of your identity provider. You can also tie it in with IAM, which means that people can get access to cloud resources through your gateway. So that's a good way if you need, for example, an S3 bucket for people to store files in, then you would add that. And you can also add use an API key, which sounds secure, but it's actually not, because it's just a fixed key that people send with every request. And it's actually hard-coded in the front end. So it means that people that don't use your front end probably don't know what your API key is. But whenever someone has used your front end, they can keep on calling your API with that API key. And so that's only suggested for either development locally or whenever you want to make your API public, then you would use an API key. So for AppSync, I describe it as GraphQL as a service. And what it does is it exposes a GraphQL endpoint, but is really flexible about where the data is actually stored and where the data is coming from whenever you do a query. So AppSync is nothing more than the GraphQL, and the rest is up to you. So after the GraphQL has come in, your query or your mutation has to be changed in some way so that it's actually supported by the service that you're using behind AppSync. So in the demo, I was using DynamoDB, and that's all set up by Amplify. But it's important to know that Amplify just relies on the AppSync functionality to actually provide that API functionality. And what happens is that whenever I did a GraphQL query, like when I wrote a to-do, the query or the mutation is actually sent to AppSync, and AppSync will then use resolvers, what are called resolvers, to map my input to what DynamoDB would expect it to be. And the other way around, when you read something through a GraphQL query, it will ask DynamoDB, like, give me this record, and then you can use a templating language to actually transform that into the output that AppSync would need to send and to support a GraphQL query. So it's sort of like GraphQL, but then more flexible in where the data is coming from. GraphQL itself is already, if you have a GraphQL server, it's already pretty flexible as well, but it often only connects to other like backend services. And here you could even connect it to Elasticsearch or to a Lambda, which is pretty strong as well. So whenever someone sends in a mutation, you could actually take that data and feed it to a Lambda, which can then either call another API, or it can store it in a queue and then do later processing on it. But it's pretty flexible. And with that flexibility comes some complexity as well. So when you start writing your own resolvers and connecting everything, it might get a little bit complex. But if you use Amplify to manage this for you, you can be up and running really quickly. So like I showed, I have a model. So in our demo, we used the to-do model, which is a simple item that has an ID, a name, a description, and an owner. And I specified some auth rules. But this is not enough for AppSync to actually start rolling out that backend. So this is like a superset of GraphQL, a schema definition language, because these annotations that you see, the model and the auth, they're actually from AWS. So they're not officially in the GraphQL spec. but those are AWS annotations which need to be transformed. So whenever you run Amplify push, your code is actually filtered or it passes through the GraphQL transform, which is managed by AWS, so you don't see this happening. But what it does is it takes your model or the multiple models that you have that might or might not be interconnected and transforms it into like standard GraphQL, which is actually usable by AppSync. So whenever that happens, while you're pushing, it will also take that GraphQL and create all the mapping templates for you. So if you were to write your own resolvers for AppSync and your own mapping templates, this is what you would see, like this is what you would be doing. But luckily, this has all been solved by Amplify for you. So whenever you create a model and you specify authentication annotations on it, it will in the end have an influence on the mapping templates and the way that the data is actually like fetched from DynamoDB or how it's actually put there. So this is, I think it's good to know that this is there. Often you will not have to change it if you use Amplify, but if you start using more complex scenarios, you might have to. So I think it's important to know that it's there. And it's just one of those moving parts that whenever you see someone demo Amplify, this is never shown. But this is there is some ugliness, and this is it. And this is the ugliness that you see whenever you browse through the AWS console. But with our backend pushed, it's really simple to actually call the API. And the only thing you need to do is call api.graphql with a GraphQL operation, in this case, listing to-dos. And it will be transformed into a query on our API endpoint, including any authentication tokens, if they're there. And if it all works out, you're going to get back a set of to-dos that you can just use in your component. So this is the way to actually fetch something. By using AppSync, you also get support for these subscriptions. So I touched upon this briefly, but subscriptions are a WebSocket that you connect to, which will keep you in sync with any of the upstream changes in the DynamoDB table. So the DynamoDB table, the data that's coming in or that is deleted or updated will be streamed back through AppSync as well to all the devices or to all the clients, which means that you can be if you need to build a chat application and people type in something and it needs to appear at another place as well, then this is the feature that you would use. And this is actually one of the bigger benefits, I think, of using this setup. And you also have a lot of control over it. So like what you can subscribe on, who can subscribe, it's all configurable, although some of these parts are relatively complex to do, but it's all configurable, and you at least have some idea of where the data is coming from or how it's all interconnected. While there are some other platforms where you would say, yeah, please subscribe to this, but you have no clue how it works under the hood. And for AppSync and Amplify, you at least have an idea of how it's set up, and you have influence over it. So that's the setup that we had in short. So let me check if there are no questions yet. If you have any questions, just send them in the comments section. You should be able, if you have an account, you should be able to send anything. And if you have any questions, I'll answer them. Until then, I'll keep going. So, like the Amplify categories that I've shown, auth, hosting, API, they're not the only ones. There are some more categories that you can add to your application. And in essence, the workflow for all of these is the same. So you would do an Amplify add and then a category. You would push it, and then your resources are going to get created in the cloud. So you could use it for analytics, like to collect clickstream data, or use Pinpoint to target certain groups of people for A/B testing or whatever. You can have function support, which means Lambda functions. So you can call them from your application or from your backend and integrate with those. You can build a chatbot with Amplify, notifications for React Native apps. So if you're going to do a mobile app, then you can have push notifications. You can do predictions on all kinds of data, AI, or you can do like machine translation. All the AWS most of the AI services are supported. You can add storage, so that's the the thing you would use if you want to store user files like photos or data. And you want to store it in blob storage. You just put it in S3 and it's going to work. And another thing, and at some point I have the feeling that it's going to get weird, but now they have added XR to Amplify, which means that you can make AR and VR applications using Amplify with Sumerian. And I kind of feel that they're moving into like a golden hammer type of setup where Amplify can do anything, which is good because it can do anything, but it's also not good because nobody has a clue what the hell Amplify is, because it does just too much. So why, in short, is Amplify cool? Well, the first thing is that you're going to get serverless for free, like literally and also figuratively speaking. So it's free in the sense you don't have to worry about how to set it up and what the best practices are, and if your application is going to be scalable or not. And it's also going to be free in the sense that most of these services that you're actually using have a pretty big free tier. So for Lambda functions, I think you can call 1 million Lambda invocations per month, and then you're not paying anything. And DynamoDB has recently also moved to a pay-per-request kind of payment setup. So you don't pay a fixed price per month for the provision throughput, but you only pay for the actual usage, which is what you would want in a serverless environment. CloudFront S3, you have to be a really large player to actually start racking up a bill with those services. I've almost never seen it happen, or maybe like $5 a month, but not much. And of course, one of the cool things is that your application is going to be scalable out of the box. So I just set up this application, but if this to-do app was going to get really popular, I could, without worrying about the infrastructure or if I've provisioned enough resources, this will actually work and keep on working, and also hopefully be fast. You can get started really quickly, so you can be up and running within a few hours or even faster if you don't run into some kind of weird issue that I was just running into. But yeah, at least it helps you to build an app, a full stack application in like a relatively small amount of time. So if I would have to set up everything that I just did by hand, which I did in the past, it is possible to just do everything in CloudFormation, for example. But then it would probably take you a few weeks to actually get this all working and connected. Especially AppSync is extensible when you need it. So if you think of a new use case that's not supported yet by AppSync, you can actually add it. So it will grow with your use case, although if you have a really complex environment with a lot of legacy applications, then I'm not sure AppSync is the way to go for you. But for starting out and growing with you, it's really good. And like I said, it's cheap or free to run depending on how big your application is or how many users you have. But within any reasonable amounts, especially here in the Netherlands, yeah, you're probably not gonna pay much. Just talking about tens of bucks in a month and not hundreds of thousands. But it's not like I said, Amplify is sort of turning into it's becoming sort of a golden hammer. It feels like you can do everything with Amplify, but it abstracts away some of the things that are actually not that easy to use. And one of the things that it abstracts away are the AppSync resolvers. So if you look at AppSync, and if you look at the code for that resolver, it actually goes on for 100+ lines. So if you would have to write it by hand, it's almost impossible to write it error-free and also test it locally, because it's a resolver and it depends on all kinds of context. The only way to actually test it is through the AWS CLI or through the UI. So you'd have to go to the AWS console, go to AppSync, and there's a small button that says test my resolver, and that's how you need to test it, which is for a developer experience not a big plus. The GraphQL transform, so that's the part that takes your really simple, small GraphQL schema and blows it up into like an enormous thing. It can sometimes be a bit iffy. So I've run into issues where it says that it's all fine, but in the end, if I look at the blown up version, things are missing. Like I missed a comma somewhere and it doesn't complain. It will just blow it up into something that you actually don't want. So you have to be really careful there. Another thing is that with Amplify and with the way that the development works, it's sort of like if you're on the path where you need to be, like if your use case is an exact fit for Amplify, it's going to be awesome. But if you need to change parts, or if you need to like override some of the default behavior, especially when it comes to authentication, then you're going to have a hard time. So at some point, you might even start changing your front end because a certain use case is not supported in the backend, which sort of like it's strange, because you would normally just change the backend to make sure that the front end stays clean. With Amplify, you sometimes have to shift that responsibility a little bit, or find out where you can actually hook in to do the changes that you need. And it's not always obvious where that actually is. So there are lots of moving parts. I've shown some of them. If you also add notifications, and if you add storage, and if you add analytics, of course, it's going to be even more complex. And there are all kinds of cloud resources behind Amplify that get created for you. But that you don't see them doesn't actually mean that they're not there. And to actually use them well, you would have to know the implementation details. And especially for DynamoDB, this is often an issue, because DynamoDB is NoSQL storage. They're pretty like strict about it. There are certain use cases and certain patterns that are just not possible to implement with DynamoDB. So to use DynamoDB effectively, you actually have to know really well how it works internally, which is often not the case when people use something like Amplify. So they just think, oh, I get a database and it's going to be a relational database. It's not a relational database, which means that you cannot just query everything. You cannot, after a few weeks or something, come up with a new query and just run it against your table. If that field was not indexed before, you're going to have a hard time to actually find it. And then you have to do a full table scan, which is, of course, going to be more expensive, because you need to scan maybe gigabytes of data to actually do the filter that you need. And then you would have to either be lucky that it is a use case that you can implement using global secondary indices on the table. But if not, then you're out of luck, and you just have to create a second table which stores two versions of the data. And yeah, it can get really complex. And also, I think Amplify might not be the best fit for split teams. So if you have a team that is like split from front end and back end, like you have separate teams for that, which happens sometime. I'm not really in favor of that, but you do see it happen. Then if you work with multiple teams on the same code base, it can be a bit annoying, because Amplify adds a few configuration files, and not all of them are actually agnostic for the account that you're using. So it's hard to manage with Amplify. For just starting out, like I said, then it's probably a good fit. So I have some things about DynamoDB, but considering the time, I'm probably gonna skip those, and hope that there are some questions. I see Marek already answered some of them. I think Lars has a good question. He asks, so would you recommend learning this stuff even if you're still a student and have not noticed the use cases for it? And a good point is, most of the stuff I build, I only get 10 to 1,000 requests a day and not millions. And then, I think it's still worth it to learn this. Although I would start out with using Amplify, and don't bother too much about the underlying technology for it. So if you have a simple app with, let's say, 1,000 users, and you want to get it live ASAP, please don't bother learning internals of DynamoDB before you start using it. You're probably fine with the tools you're going to use and the tools you're going to get out of Amplify. It can only become a problem when your functionality needs to scale, because at some point you might hit a point where the defaults and the standard settings are not going to fit your use case. And that's the point that either you would have to like re-implement parts of your stack in a different way, or like spin off a second application. There are options, but in the long run, it can be harder to actually keep everything clean and keep it within the Amplify framework. And it really depends on how much you want it to be inside that Amplify framework. And in my opinion, you want it to be inside because those are best practices and it requires no maintenance. It's scalable. So if you stay within the constraints of Amplify, you'll know at least that you're not paying too much, that your app is scalable, and that you won't have to do any maintenance on it or keep it running or stuff like that. Yeah, and then the last question, and then it's time. There's questions about Firebase, and that Amplify seems almost the same. Yes, there are similarities between Firebase, especially when it comes to Firebase hosting or Firebase functions. I think those are a direct like match of what Amplify can do for you. But especially AppSync, I think is a big added value on top of Amplify. So with Firebase, you have Firestore, which is their real-time data storage. It's also NoSQL storage, so it resembles DynamoDB a little bit. But with Amplify, you get, or at least AppSync, so that's what powers Amplify. You get the benefits of being able to write your own resolvers and hooking it up to different types of data sources. While with Firestore, often people will just use Firestore. And even with Firestore, it's really hard to do it correctly because I've seen people use Firestore in such a way that it was their complete backend, and they had logic programmed into Firestore based on all kinds of booleans, and it was horrible to maintain. And with AppSync, I think you have more options, and first you're probably not going to see them, but as soon as you see those options and see what it can add on top of Firebase, yeah, then you'll see that it's actually a different product. So they look similar, but they're not that similar as they seem to be from first glance. Yeah, and I think you already commented that he said having used Firebase more than Amplify, it does look like that Amplify is AWS's Firebase, and yeah, I think you can agree there. So it's their developer enabler. It's like the product that they use to make you build applications really fast. And it's a product that adheres to serverless best practices. So in that sense, it's actually comparable to like Firebase and Amplify are comparable. But like I said, if you look a bit closer, you'll notice the differences and how they can benefit you in the long run. Okay, so that's it. The time is up. I'm 2 minutes past my time. Thank you for watching. Sorry that the demo didn't work out. Yeah, but I hope that at least you had fun. I can I'll send you the link afterwards where you can find the code for this demo, and then you can try it on your machine and your account, and then hopefully it's going to work. Thank you for watching.
Yes, Leon, thank you very much. We here at the IJ, we enjoyed it. We enjoyed your talk very much. I would like to especially thank you for taking the courage to do a live demo. From what I've seen, from what AWS Amplify can do, this most certainly works. So let's put it to bad fortune this time. But still, thank you very much. I would like to take a 10-minute break and in 10 minutes continue with our next talk. Our next speaker is Marek Kuczynski, who will take us through AWS Cloud Development Kit and show us what deployments can do. So let's take a 10-minute break, grab a beer, and see you then. Hello, everyone. Welcome back to the second talk we're having tonight about AWS Cloud Cloud Development Kit. I'm sorry. I briefly introduced this a few minutes ago. Let's hear Mark about this topic. I'd like to give the floor to you, Mark. Let's have a go.
Great, thank you so much. Hopefully everyone can hear me and you can also see my screen. So yeah, in the next hour or so, I'm going to be talking about the Cloud Development Kit. I'll also, just as Leon, I'll keep it in English. I know there's a couple of English-speaking friends looking as well, so hi to everyone. But in either case, yeah, my name is Marek. I'm a senior serverless solution architect at Amazon Web Services. I'm based in The Hague myself, so actually not that far away from you. And I work mainly with customers actually in the Benelux, but also a little bit broader in EMEA, with anything related to serverless on our platform, right? So I work with customers on their serverless architectures, on any feature improvements that they may have, and also on refining a little bit further, for example, the roadmap of the various services that we have available, right? So in that perspective, I'm a little bit, you could say, in between our teams that are developing a lot of these things, mainly in Seattle, and a lot of our customers and developers or people that are thinking to start adopting serverless as well. Yeah, and it's one of the parts of my job also is to educate people and basically collect feedback. So participating in these type of meetups is actually a really good opportunity for me as well to, learn first of all on what you think is interesting, what we should be developing more, and so on and so on. So yeah, in that sense, also please feel free to just ask any question on the chat in the meantime. It can be related to the content that I'm going to be talking about, but it could be about something else serverless as well. And afterwards, I'll share my details as well, like my email or my Twitter, where you can reach out to me as well. Yeah. So the topic today, for my session at least, is the Cloud Development Kit. You can already see on the slide that it's quite a mouthful, so I'll just call it CDK from now. And it's actually, yeah, one of the more recent development frameworks that we've created from Amazon perspective. And you'll see a little bit throughout this presentation, when you could be using it. What are kind of good starting points? I'll also have a couple of demos in there just to show you a little bit how this Cloud Development Kit works and how it fits in. And a bit towards the end, I'll also compare what I've been showing you right now with CDK compared to some of the other frameworks that are available. So I'll have a bit of a comparison, for example, to Amplify, which of course Leon talked a lot about already. But I'll compare this also a little bit to, for example, the serverless application model, what people might be doing with Terraform, or some of the other development frameworks as well. Yeah. So just as a bit of an introduction, I work as a serverless architect. So that means that I work a lot with Lambda, API Gateway, DynamoDB, and those type of things. And sometimes customers actually ask me, like, what's the whole point of serverless? Like, we're maybe fully on Kubernetes, or we're on-premise even, or we're using maybe a different solution. I think what's kind of the big philosophy and the idea behind serverless, and why we're also from AWS side investing a lot of time in it, is that it's not really about the technology itself, right? Which is pretty cool, and hopefully you'll see a bit how we think about that and how we develop that as well. But I think kind of the biggest takeaway eventually is to take away as much as possible the heavy lifting that developers have to do, right? So like Leon was showing you already, and I saw a bit of a discussion as well, what's the whole point about Amplify? It's really around creating and building applications as soon as possible, right? So if you, at a certain point, you've got the hang of it, just as Leon does, you can very quickly create websites. You can start extending them. You can start iterating them as well. And yeah, kind of the whole serverless ecosystem is all about that, right? So how can we basically take away all the heavy lifting, make sure that you don't have to worry about backups, about storage, about kind of the things that are undifferentiated, but really focus on, for example, making a better app, a faster performing application, and so on. So in my talk, actually, I will be talking a lot about the Cloud Development Kit. So I'll explain in just a minute what that actually is and how that works. But I'll also be talking about both Lambda functions and Fargate containers, right? So you will see a little bit that I will touch upon, containers and functions. And I wanted to just take kind of a minute to explain a little bit the terminology and also how these features fit in, right? So if you look a little bit at this picture, you should look here at kind of the level of abstraction, which is the x-axis, and also the focus on business logic, which is the y-axis, right? So around 10 to 15 years ago, when I, for example, started my career in IT, we only had physical machines, right? So the thing that you see here on the left, basically what that meant was that IT development in general was super slow, right? You basically, whenever you wanted to start a website, you had to actually order a physical hardware for that. So, maybe you had to call Dell or HP or whatever. They would ship a server to you. And then after maybe 3 months or so, you actually had an operational website up and running, right? Then somewhere around probably 10 years ago, we started using more and more virtual machines. We actually first started doing this, of course, on-premise, right? With Hyper-V, with VMware, with all kind of other orchestrators for virtual machines. And the benefit here, of course, was that we already could develop a little bit faster, right? So instead of maybe having to actually order that hardware device, we could now actually go ahead and just in a quicker way spin up a virtual machine. Then probably in the last 5 years or so, mainly due to Kubernetes, containerization became actually super popular, right? So containers offer you even more benefits of virtual machines. Deployment time goes from minutes towards seconds. You also have an easier footprint just to share these containers, right? Since you don't have to actually copy paste virtual machines, but you can just copy a Docker file. This is already, again, bringing us a little bit closer towards that nirvana, right? Of basically having infrastructure available as we want to have it. And that kind of brings us to today, right? So to the top, to the logos that you see on the top right. What we kind of consider as being serverless options, both of them going forward from AWS's perspective, are both Lambda, right? So that's a little bit what Léon talked about as well. Those are basically functions. So small pieces of code that can run up to 15 minutes on managed hardware that we have available. And this is typically, if you have event-driven architectures, this is a really good starting point for you to start using. In case you don't have that luxury and maybe you cannot adopt Lambda, and there can be many reasons. I'm not going to go into too much detail here, but happy to chat with you offline if you're a little bit in this trade-off. Like we see kind of like the fallback option to that is probably AWS Fargate, right? And Fargate is kind of our fancy name for having the opportunity to take a container, run it on a managed platform that we actually patch for you, that we do all the maintenance for you, and where basically you can really start focusing on maintaining just that container image and, making a better application. But we try to take away all of the, difficult heavy lifting away for you, right? So Lambda and Fargate in that sense are kind of the two compute options that we kind of see being used by most of our customers going forward. And just before we actually start diving into CDK, because this will be important later on, here I've written out a little bit the, very simply also the differences between instances or virtual machines, containers, and what are then functions, right? And you see that kind of the difference is on one side between the startup speed, which will be fastest, for example, with Lambda functions. But on the other side, the Lambda especially is also very opinionated, as I was saying as well, right? So in many cases, you need to kind of do things the serverless or the Lambda way in order for it to work. And then you benefit from all the benefits as well. But again, we would kind of advise you take a look at Fargate in case that doesn't work out for you. And in my demos and throughout this talk, you will be seeing mostly Fargate and Lambda being used kind of side by side as well. So kind of the last maybe setting the scene slide before we actually go into content itself. From our perspective, serverless is a very broadly used term. It seems to be as popular maybe as blockchain or big data were 2 or 3 years ago, right? Everyone is doing things serverless now. From our perspective, from AWS perspective, what we like to share as well is that serverless to us is way broader than just compute, right? So I don't think ever that just Lambda functions are something that you can build an application with, just as you cannot really build a full application with Kubernetes either. That's probably worthwhile a debate to what extent you should be using just one service or to what extent you should be using the rest of the ecosystem. But, kind of the takeaway message here is that whether you're using Lambda or whether you're using Fargate, that's just going to be the compute part. So the part where your code is actually running. You will pretty much always need to have some sort of solution to, maybe maintain state as well, maintain some storage, or maybe even do messaging in between some of these services as well, right? So this is just a bit of a snapshot of some of the services that we have available. I know that Léon talked about a couple of them as well, so I'm not going to recap too much of it. But it's in our, you should always, I think around how can I actually create new applications where I, pick kind of like the easiest option and also the easiest one for me to maintain on both the compute side, on the data storage side, and on the integration part, right? And especially with that integration part, that part is probably more critical with serverless architecture than it is with, more monolithical or more virtual machine-based architectures, since you will have a lot more different components, right? You will typically have a lot of very small microservices or maybe AWS services that do something for you. And that's where, of course, having a queue or having some sort of notification service becomes really important. And maybe just as kind of like the last setting the scene picture, but I think Léon already got you in the right mood, kind of. Modern applications in that sense also look very differently than applications as we used to create them in the past, right? So you will see more often that components can be interchanged, right? You see here on the top side, you see the Amplify logo, which of course Léon showed you everything about. But once, for example, you could use Amplify, there might be third-party solutions to host your website. And just as you can replace kind of that front end and that presentation layer, you should be thinking the same way about also how you do the business logic part, right? So that's kind of what we would have called maybe middleware in the past, where you pass messages from the presentation layer to the backend layer. And the same actually definitely goes also for the data layer, right? So there's so many databases available today, ranging from DynamoDB to, QLDB, if you maybe need to have some sort of quantum properties and so on, that modern architectures, if anything, are around, agility and having the opportunity to change these components as you want to as well. So I'll skip a little bit over the Lambda section. I think Léon talked about that already. And I'm going to actually talk more about infrastructure as code, right? So infrastructure as code, I think, is also a, should be hopefully a pretty known term by now. And hopefully if you're running, either on AWS or any other cloud provider, you've already adopted this infrastructure as code approach. But I'll just quickly explain to you a little bit how we look at that and what also the different levels are of how you can actually do IAC. So, how I, for example, started with AWS. So I've been an AWS customer now probably for 6 or 7 years or something like that. And when I initially started actually using the platform, first of all, there weren't that many infrastructure as code tools available back then. I think CloudFormation was already there, but I, for example, started my career initially by creating a lot of this infrastructure by hand, right? So if you're doing these type of projects solo, that's typically an okay approach to get started, right? It's pretty easy to keep an oversight, and in the console, you can do that quite easily as well. But you can already start imagining, as you see in this diagram as well, once you start doing this with multiple people, things can get a little bit tricky fast, right? Like who actually created the server, who shut it down, who actually made a modification. That becomes a little bit difficult to trace and to also potentially roll back, right? So what people started doing probably like, I don't know, a couple of years ago already is, of course, people started thinking, hey, if I can, if I have these repeatable steps, for example, to create my web server or my database or to do a new deployment, I can maybe start putting that in a script as well. And then actually using the AWS CDK, I can maybe start automating more and more things, right? Why would you focus on maybe doing the same manual steps every time that you do a deploy or you launch a beta service, if you can also create a simple script, right? And I think a lot of you will know already what a script is, right? It could be in Bash, it could be in Python or whatsoever. But basically, you would use kind of an imperative way to structure and to actually define how your infrastructure would be created, right? It could be with if-then-else loops or anything else like that. But as you also see here on the slide on the right side, this isn't foolproof, right? So if 2 people run this script, you don't really know what's exactly going to happen. You might have particular race conditions, right, where things actually get provisioned in the wrong order and then stuff starts breaking afterwards. And there's also a lot of boilerplate, right? So there's a lot of things that you need to develop that don't really add any value. Again, we would ideally have you focus on really the creating better applications and not spend too much time on actually provisioning or scripting any infrastructure tasks that can be avoided. So, couple of years later, especially I think initially like 5 years ago or so, I've noticed that a lot of people started using Terraform, right? Terraform is still used by, I would say, a very significant part of my customers today. And what customers especially like about Terraform is the plugins that are available. Also, I think the speed in which the tool evolves and also allows you to abstract away a lot of the infrastructure that you might have. So what actually happens, and what's maybe different compared to the imperative infrastructure as code, which is scripting, is that in this case, you could do it in a declarative type of way. You can either use, as in with HashiCorp has, for example, HCL. So they have their own translation layer kind of to go from, describing your infrastructure to actually creating the API commands. With CloudFormation, so that is the AWS native kind of option, you would actually define this infrastructure over, I think I have that on my next slide, over very long YAML templates, right? So it is a step forward in the way that you can, very clearly define what is the infrastructure, what are some of the properties that could be there. Since we've made that switch also to YAML a couple of years ago, you could kind of consider, this becomes relatively readable, right? I can, for example, see that a VPC is being defined here. I can also see that subnets are being created and so on. So, it is already, again, another step forward when it comes to creating infrastructure. Another example, and I'll just take a small sidestep here, especially since I work a lot on serverless. Another good example, I think, of this templated language, which is actually an extension of CloudFormation, is the serverless application model. I think that some of you, maybe if you've worked with Lambda or API Gateway, may have heard about this before or may have used it as well. But basically, the idea behind it is that, CloudFormation is a very verbose language. I'll show you just a couple of minutes and stats, stats in a minute around, how much code it might take to define your infrastructure. What we've tried to do with the SAM project a couple of years ago is to actually kind of simplify and reduce the amount of boilerplate code that you need to do, right? So if you look a little bit at this example, this goes into a lot of detail. If you just do it with CloudFormation itself, you can literally configure every, minor detail that you have available over here. And that does give you a lot of control, but also, kind of pollutes your templates and makes it maybe a little bit difficult to start. What we did with SAM is we've basically kind of created a dialect of CloudFormation, you could say, right? That's the transform that you see on line number 2 of the slide. And what that basically allows you to do is to use less code to create serverless applications. So with these 20 or so lines of code that you see over here, you would actually be able to provision a serverless function, an API gateway, and then a DynamoDB table at the bottom, right? So this is, by the way, also, I'm going to show you in just a minute what kind of like next level things are on how you can create this infrastructure. But for me personally, this is actually still how I built a lot of the serverless tooling as well, right? So if you take a look at my GitHub or that of my colleagues, we actually tend to like this structure itself because it's kind of concise. You can kind of like learn the syntax and how to build a full serverless application this type of way. And it's just kind of like simple and easy enough to deploy applications there, right? However, let me now show you kind of the new kid on the block, right? And also the one that's kind of like the main part of my presentation today. And that's the AWS Cloud Development Kit, right? So that's called the CDK. So what the CDK actually does is, we call it like, again, level 3 kind of development, so the next level. What actually is the nice thing here is that developers can edit the source code of both their applications, but also of the infrastructure in the language that they prefer, right? So what you see a little bit here in the illustration is that there's now, for example, 2 developers that might be actually preferring Node.js, or it might as well just be Python or .NET or any of the other languages that we have available. And kind of the big benefit of the CDK is that they don't really need to learn any new tooling or any new programming languages or any new abstractions. They can just go ahead and, for example, write their application in Node.js, but also define the infrastructure in that type of way, right? And what we will then actually do is we will parse that. There is a CDK CLI, which you'll see a little bit in my demos later. And that's actually the component that then creates it and translates a CloudFormation template and eventually also creates the infrastructure, right? So again, this is the way that we see it, is really just around taking away the friction that developers might have with creating infrastructure as code and just making kind of like that part of where you might be experimenting with new features or services, or where you want to make iterative changes to your applications, just much, much, much simpler for everyone to grasp. So how does that then look like? I've just put a couple of very small examples here on the slide. I'll dive into the console in just a minute. But what it actually means is that you will have on one side, you will define your CDK application, basically with all of the various components that you want to have available. So what you see here on the top side is just a bit of Node.js code on what it takes to basically define a Lambda function, right? So you can see that we basically just call the Lambda function class. We specify what the runtime should be. In this case, we want it to be, for example, Python 3.8. And we specify, what is the folder actually that our source code will be available in. If I were to just simply deploy this CDK application, and I'll do something similar with a demo in just a minute, then I will have basically a fully fledged Lambda function just configured, right? So no CloudFormation, no YAML, no, any difficult ways, no scripts or whatever, just pure Node.js in this case, in order for me to create this application. And then kind of like what I was mentioning as well, the nice thing as well is that I could either use Node.js as well for my Lambda function. That's kind of the bottom part of this slide, which, in this case, is just a very simple return that I do. But this could be any language as well, right? So I can basically interchange both the CDK language that I create my infrastructure in or the language of my code. It really doesn't matter. We're giving you basically the full freedom there just to pick the languages and the constructs that are the simplest one for you to use. So before I actually dive into some of the demos as well, why does this make sense? Because, okay, it's cool. I can maybe use Python or Node.js. I don't have to learn CloudFormation or edit YAML files all day. But what's actually like really kind of the killer feature, right? Like why should I look into this? Well, I think one of the massive abstractions I think that we've really got right in CDK is that there's just a lot of things in AWS that are just very tedious and very painful to configure if you want to do it in CloudFormation or maybe even in Terraform or any of the other third-party tools, right? So kind of like the most powerful example that I can show you is what it takes to create a VPC, right? So a VPC, for those of you that may not be aware, that's basically like a virtual private network that you create in AWS. You would typically configure it with a subnet. You would also configure how many availability zones, so basically how many separate data center facilities it uses. And you can do all type of things in there as well, right? Like, is this VPC, for example, connected to the internet, or can it only go outbound with a NAT gateway, and so on and so on. So what I can actually do over here is I could use, for example, this one-liner that you see on the top of my screen, put it in a CDK template, run CDK deploy, and what actually will happen at that point in time is that with just these one line of code actually that I have on the top side, I actually saved, I didn't have to write 270 lines of CloudFormation, just because we, with this example over here that you see on the top side, one of the things that we started doing is just picking kind of sane defaults, right? So what we typically see is that when customers create VPCs is, they'll typically always want to have a public and a private subnet available. They'll also want to have maybe a NAT gateway, or they'll also, if you create a VPC, you'll also want to have a routing table. So we don't really have to ask the customer to specify that. We just have kind of like simple defaults that are in there. You can modify them quite easily as well, right? So for example, in this case, I'm specifying that I want to use maybe only 2 availability zones instead of 3. You can just simply add that with a simple command. And kind of like the killer feature for me, at least at the end of the day, is that I can skip defining and writing all of this CloudFormation code that eventually could maybe take me half a day or a lot of copy pasting from forums to get right. But I basically don't have to do any of that, right? I can use a very simple construct, as we call it, to do this straight away for me. Now, one of the other things before I dive into the demo as well that I wanted to show you, and I can actually maybe just show you the easiest way, instead of on a screenshot, I'll just show you a little bit how these documentation work and how you can use this. So if I just, for example, look for the Lambda construct, right? This is the one that I had just on the screenshot just a minute ago. I've mentioned to you already that this is actually, this works with multiple programming languages. So I could define my infrastructure with TypeScript, which is typically where what we use to show the default examples with. But if I'm, for example, a Python developer, I can very easily just click into the Python docs and, for example, see very easily, what is actually the code and what are some of the methods that I can use to create a function in Python, right? So in this case, the syntax will be a little bit different. The classes will be called a little bit different. Node.js, for example, will typically have kind of like this camel casing thing. With Python, the syntax is a little bit different. But basically, all of the methods, like the one that you see over here for a Lambda function, conceptually and feature-wise, they're exactly the same, right? So I don't really have any restrictions depending on the language that I can use. But what we actually do underwater here, because you might be wondering a little bit, hey, that's interesting, right? So you have kind of, you're adding, I can use this basically with different languages, like, you know, is this actually maybe a risk for me if I use it with Java instead of Python or anything like that? What we actually did with the CDK, and this is kind of like Word to Topic on its own, is that we kind of cross-compile between all of these various languages that you have available here. So if I, for example, specify the CDK template in Python, we will actually, within the CDK library, we will actually translate that back into TypeScript code, right? So we have a very clever translation mechanism that can basically translate all of the code that you write into TypeScript, and we then actually use TypeScript to create the templates and to deploy them and so on, right? So this is kind of like one of the things that you don't really have to worry about as a user, but it's maybe an interesting thing to understand a bit, like, how did we build this and how do we actually ensure that it also stays compatible and that, you know, basically features stay the same regardless of the platform that you use. So now that I've already switched a little bit away from my slides, let me just show you very quickly how to deploy such an application. There's going to be a little bit of a demo that I could mess up. Let's hope it works. In the worst case, you know, you could take a look at the source code that I have available here. And let me just quickly walk you through how this actually works, right? So what I'm going to be doing here in this case, I wanted to just show a very simple template that I would deploy from scratch so that you can get a little bit the grasp of it. And my template is actually kind of like the standard serverless template, right? So it has an API gateway and then a Python Lambda function that just basically return back a response, right? Just a simple hello world, basically, just to test if this all works. Now, you can, of course, go ahead and copy this repo yourself and maybe play along. But I've already cloned it and put it on my machine. So what actually happens whenever I create a CDK project is it will go ahead and create a couple of bootstrap files for me already, right? One of these files that actually gets put into the folder Hello World CDK is the so-called Hello World CDK stack, which I'm going to just open right now just to walk you a little bit over it. But the idea behind this, let me just make it a bit smaller. I'm trying to keep my resolution as big as possible so that everyone can follow along at home. But kind of, or maybe make it a bit smaller because it might be really difficult and a lot of scrolling. But over here, you can actually see how I've defined this very simple Hello World stack, right? So the code that you see over here, like the classes and those type of things, this is basically standard CDK syntax, right? This is basically stuff that you don't really have to touch, just leave it intact. But where you can actually start editing code is kind of, you know, you can go ahead, pick up this template, and then just start adding AWS components, right? So the way that I started, for example, creating this function initially was I've just added I've looked at the AWS documentation and I found this function that I was just showing you a minute ago as well. I can actually, another nice thing that I like about this development as well, which is really different, I think, from developing a CloudFormation or some of these other frameworks as well, is that I actually, in VS Code, for example, as you see on my screen right here, I can automatically with IntelliSense, so that's kind of like the documentation lookup that VS Code has, I can very easily see, and just as I type, see what some of those various properties are that I can add to one of the constructs, right? So I start with Lambda function, I just key it in over here, and it will already kind of give me a couple of examples and things that I can do, and what are some of the method calls that I can do. But like, just as an example, if actually this Lambda function was written in, maybe Node.js and not in Python, what I can actually start doing, and this is often the way that I start developing as well, is I just use kind of the autocomplete over here, right? So I could, for example, make it a Go function. I could also make it maybe a Node.js function, and I kind of like just type and autocomplete kind of my templates all together, kind of going over this template until I have it available and until it's ready, right? So in this case, I'll just leave it on Python 3.8, else my deployment will fail. But yeah, this is another, I think, very powerful feature that I can just look up very quickly the documentation, iterate with things, and add other components as well. The other thing, of course, that we need for this function as well is one thing is, of course, creating the function and uploading the source code and configuring the memory and those type of things. The other thing that I need to do as well is to create an API gateway, right? So that would be the component that actually allows people from the browser, for example, or through a CLI client to connect to it and to receive back the response as well, right? So the way that this actually works, and this is where I'm going to try to actually execute this template. Once I'm happy with actually creating it, let me just show you quickly. I've also created a very simple Lambda function. So nothing too special, just a very simple return that says, hello from Lambda deployed using the CDK. This could, of course, contain any Lambda code that you want to have available as well, right? You would basically do exactly the same thing that you do with a Lambda function that you maybe deploy with CloudFormation or with Terraform. You would specify the handler. So basically, what is the starting point that your script should be running? And then it will go ahead and basically start executing your code from there, right? So in this case, actually, I've placed it, as you may have seen, in the /lambda folder, which I've referenced as well to in the CDK template over here, right? So fingers crossed, we're going to try to see actually if we can see. First of all, I'm going to try to see, now that I defined this template, how can I actually see what is the CloudFormation code that it would result into, right? So in order to do that, actually on the command line, I can just run CDK synth, which stands for synthesize. And in that case, actually what we do, it's probably going to be a lot of code, we actually generate the full CloudFormation template for you that actually comes from the CDK stack, right? So I'm not going to show you the full thing of it. I think you can already see a little bit by the amount of scrolling that I'm doing that it's pretty massive, right? It's defining IAM policies. It's defining, where the Lambda code will be stored. It's doing a lot of things that I really don't want to worry about, right? I just basically want to deploy this application as soon as possible. And, kind of the nice feature here is that CDK does that automatically for me. So maybe just as a small experiment, I showed you just a minute ago, of course, that we saved 270 lines of code with the VPC example. Let's see a little bit how much it's going to be here. So over here, actually, you see that this small basic template of 30 lines of code actually would have been 396 lines of CloudFormation already, right? So that's already mind-boggling to me. You can imagine that if I were to add DynamoDB tables, a VPC, and all type of other stuff, that's probably going to be like a few thousand lines of CloudFormation code very easily, right? So if you kind of weren't maybe convinced yet of the fact that there is a simpler way than using CloudFormation, hopefully this convinces you, right? So we've generated kind of locally the CloudFormation code. We can inspect it, but in this case, I know that it's going to be working correctly. We can now actually go and start ahead and try to do a deploy, right? So whenever we click deploy, what actually will happen is that, first of all, I'll make this a little bit bigger. CDK will kind of pick up the CDK stack that I have available over here. It will do a little bit of syntax checking on it. So it will check, for example, if I would have entered Python 4 here, it should give me an error that says like, hey, I don't know what Python 4 is. You probably have a typo. And it will then actually go ahead and, as you can see on my screen over here, I'll make it a little bit smaller so that it's more readable. It will actually just kind of ask me for a confirmation, right? So, hey, I'm good to go to deploy your stack. I just want to make sure that you know that I'm going to be doing some things on identity and access management level. Just give me quickly the approval for it. So sure, right? I'm happy with that. And actually underwater, it will now go ahead and start creating that CloudFormation change set, right? So it already went from creating this or kind of translating this CDK stack into CloudFormation. Now it's going to be basically just deploying it in CloudFormation as you may have used already in the past with regular CloudFormation, right? So I can maybe quickly just show you that this is actually a live demo as well. You see actually right now within my AWS account, within the CloudFormation console, that this new stack Hello World CDK is creating. And we will be seeing, hopefully within just a minute, that all of these various resources are being created for us, right? So demo seems to be working. It seems like the resources are being created. I can, of course, go into the console and follow it along here. But what's kind of nice about the CDK as well is that you can even, like with this little progress bar, just basically see, what is it doing now? Is it successful? Is there maybe an error I need to take a look at or whatsoever, right? So this typically takes like 1 or 2 minutes to deploy. And after that, we should have a full ready-made infrastructure that we can take a look at, right? So I'll let this run for just a minute. Seems to be almost ready, I think. So maybe it's speeding up now. But if all goes well, based on this code, actually, I should have a fully functioning mini serverless deployment in just a minute that, you could, as mentioned already, you could clone my repository, run it on your machine. The only thing you'll need to do is download the CDK and actually configure it a little bit. But afterwards, you can just immediately go ahead and start playing, for example, with this sample. So if we now click on the link that I just, maybe good to highlight. So in CDK, actually, by default, we output also helpful commands for you or stats about your CloudFormation stack. And in this case, actually, it printed out the URL of the newly created API gateway that was, of course, created specifically for this demo. And whenever I click it immediately on it, I can basically see the output from the Lambda function, right? So the stack is operational, it works, and I've just deployed a very simple architecture like this. So let me move on actually to, I'm going to talk for just a couple of minutes more around how this works for containers, right? So I personally see that, if you ask a little bit for my opinion, then probably the serverless application model that I showed you before, right? So kind of like the YAML-based syntax for creating serverless applications. Compared to CDK, I would probably say that at this point in time, I kind of use both of them. Both have their pros and cons. But with serverless, you already had, of course, a lot of different abstractions available. So with serverless, actually, I would say that the CDK is something that's pretty helpful. But with containers especially, where you definitely need to have VPCs and security groups and maybe a service mesh and a container registry and 100 other components, that's especially where I see CDK as being is quite interesting. So let me talk just for a little bit about how that works. So whenever we were to be deploying, for example, something using ECS, right? That's the Elastic Container Service. So the native AWS service that can be used to create and deploy containers. There's actually two interesting constructs that you can use there. There's, first of all, the regular ECS library, right? So that's where you can go ahead and create a cluster, a service, a task, kind of like all of the things that you would be typically doing within the ECS console itself. The very interesting thing, and the thing that I want to highlight to you, is actually the one on the bottom, right? So the one where you can actually use predefined patterns that we've already developed for you, and that actually give you a full combination of multiple AWS services already linked together. So, just to give you a bit of an idea, how would it look like actually whenever we want to create maybe just a container image? You see over here, we would go ahead and import ECS, right? In this case, we're doing it again in Node.js, but it would pretty much work the same way in Python as well, or any of the other languages we have. And for example, over here, whenever we just specify, we want to use ECS container image and we want to run it from an asset, what we actually will do underwater is we will run the Docker build locally on your machine. We will upload it towards the EC2 container registry, right? AKA ECR. And basically, it takes for you, 2 lines of code for you to build and upload your container already towards ECR, where you could start using it for different type of purposes. I'll skip a little bit over this one. I wanted to show you more like the higher level constructs on how little code it can actually take for you to create, for example, a load balance service using the CDK. So whenever we take a look at, for example, the ECS pattern that is there for load balance services, you can see it actually kind of in the middle of the screen with ECS patterns in red, load balance services. What actually this pattern will do for us automatically in roughly, what's this going to be, like 10, 15 lines of code altogether, is it will create a load balancer for us, the ECS cluster. It will upload the container images locally from our machine and basically create a fully horizontally scaling stack for us out of the box, right? I mean, it's literally, you can see that this is, at least to me, and I think to a lot of people as well, this is pretty readable code, pretty comprehensible as well. And the fact that you can actually, from scratch bootstrap a fully load balanced Fargate cluster with a load balancer up front, that's pretty magical, of course, right? So this is another super powerful pattern, I think, that I see a lot of ECS, but also EKS customers, right? So you can do similar things with Kubernetes as well. this is where I really see a lot of customers that they start loving it and really start adopting CDK en masse. A couple of other ideas, right, to maybe inspire you a little bit further. So what if you're not using your containers maybe for web-facing traffic, but you're actually using these containers to maybe, pull messages of a queue and do kind of like a backend asynchronous processing. Maybe you actually have some sort of backend process where, you put URLs or other references on an SQS queue, and you want then containers basically to download, basically receive those messages, do some sort of conversion step that maybe takes a couple of seconds, and then basically pick it up again, right? So kind of like a typical pops-up scenario where you want the containers to automatically start up, but to also start reading from that SQS queue. We also have another pattern available for that, right? So in this case, what it will actually do is it will give the containers that will be provisioned in your ECS cluster the necessary permissions to already read messages from the SQS queue. And we also already go ahead and, for example, create the auto-scaling policies for you, right? So that in this case, actually, in this example, we hard-coded towards 3, right? So you could have a reason and maybe say, hey, I want to, at any point in time, I want to have 3 of these containers running because maybe I have a consistent amount of load that's coming in. But if you were to remove this desired task count, we would actually automatically scale the amount of containers based on the amount of messages that are in the SQS queue. So in that case, you can really have auto-scaling out of the box and just basically have us define how much or how little containers are needed to process your traffic. I think this is the last one, actually, another very simple one. You can do similar things also with scheduled tasks. So maybe you want this container or this Lambda function, works the same way, basically, to start, for example, every day exactly at 5 o'clock. Well, again, it's just a couple of lines of code on how you could actually run, what we call here cron jobs or kind of like scheduled tasks for a very low cost with basically the minimum amount of automation that is required from you to write it, right? Again, this is less than 10 lines of code that it takes for you to define this infrastructure. So let's talk for a little bit, very quickly, because I'm running low on time. Let's talk a bit more about, you've talked about serverless, you talked about containers. What's actually kind of like the point of combining these, or where can actually CDK make this maybe a little bit easier for me to do as well? I'll skip a little bit over some of the pros and cons. I think I've talked to them already. The slides will be shared with everyone afterwards, by the way, right? So in case I skip maybe over something quickly, you can review it as well. But what I wanted to show you is actually one of the patterns that I've worked together with some of my customers recently. In this case, actually, what you see over here is an architecture where, we're using both Lambda functions, but also ECS containers to kind of process these batch functions, like I was explaining just a minute ago, right? Where we basically want to have some Lambda function that, for example, retrieves a value or retrieves some content or whatsoever. In my demo setup, it's just a random number generator, right? Because I don't really have a traffic state, but you get hopefully the idea. And then actually, what one of my customers was actually doing in this case is they actually found out that processing, they used to process these type of data using just Lambda functions. But at a certain point, they actually figured out that they might swap that for Fargate as well, right? What was actually their challenge was that they were doing video conversions and other media conversions in Lambda functions before, but they found it just a little bit too tedious and too difficult to make it always run properly within a Lambda function, right? Sometimes the Lambda would run out of memory or it wouldn't fit within this 15-minute window. So, we actually went ahead and created kind of like a hybrid architecture where they still use Lambda function wherever it makes sense, because it's the cheapest and most, worry-free mechanism for them to use. But actually by having this type of architecture where, there's actually an ECS container that kind of does the things that Lambda just, struggles a little bit to do, or where a lot of re-engineering would be required to make it work, that's where they actually use Fargate. So not going to go into much detail into this sample. I didn't actually do the thinking a little bit about my previous demo with showing how much lines of code it was. I'm going to maybe during the Q&A actually just take a look at how much lines of code in CloudFormation this would be. But my expectation is probably way over 1,000, right? If you want to have all of these components in place and, then have metrics being sent out as well, CloudWatch logging and those type of things. So yeah, let me wrap up a little bit and then see, please feel free to still submit your questions. We're going to be switching to the Q&A in just a minute. But let me just give you a couple of parting thoughts, right? Just a couple of things to consider and maybe to get you, help you get started with using CDK as well. So I've mentioned already a little bit at the start that I would, since of course, Léon bombarded you with a lot of knowledge about Amplify, I've been talking a little bit about CDK and SAM here. So I figured it might be nice to maybe, give you just a couple of, like a one-liner of when should you consider which tool. So like Léon was showing you, if you're doing anything with mobile or web application, probably go towards Amplify, right? A lot of different abstractions that are available there to create a login console or something with GraphQL or something like that. The serverless application model, so one that I talked about just very briefly, but I wanted to give you just that alternative as well, is still probably my preferred tool, just because I really like this concise YAML syntax, and because it's also very easy to create and destroy serverless applications with. So this can be maybe if CDK is a little bit of an overkill for you, or you're happy to work with YAML, definitely take a look at serverless application model, right? Especially if you're using Lambda, API Gateway, DynamoDB, and kind of like in that sphere, serverless application model is awesome, and also something that you will be able to iterate and innovate very quickly with. And then, of course, we have the cloud development kit. I would kind of say that this is the kind of the overarching deployment framework that you can basically use for anything, right? So it comes with the benefit of being able to use your own programming language, but I think also the very big benefit that you could deploy containers, instances, IoT devices, Sumerian maybe, as Léon was saying as well, maybe AR, VR solutions. Basically anything can be created with the Cloud Development Kit. And from that perspective, I think it's probably, if you were to start, let's say that you haven't done anything with AWS and you want to pick up any of these frameworks, take a look a little bit at these considerations. If you're really not sure, I think with Cloud Development Kit, you cannot go wrong, because you can basically use it to build anything. And it's also just the simplest way, I think, with the local programming language that you can start doing this yourself. Another thing that I want to highlight as well, if you start using CDK, but for that matter, actually SAM or Amplify as well, take a look at what's already available out there, right? So I've shown you a little bit what some of the ECS patterns are that can actually abstract away a lot of work that you would need to take maybe to create an ECS cluster. So, you can do it manually. That's a little bit the approach you see on the right side of the screen. Or you can use a predefined pattern that just, reduces a lot of the code that you need to deploy automatically for you. The last thing, and this is actually a feature announcement that we recently did, we're taking this also to the next level from AWS perspective, right? So I've shown you a couple of examples that I've shown you the ECS patterns. I've shown you a couple of other abstractions that are available. What we announced like 22nd of June, so like roughly 2 weeks ago, are actually what we call AWS solution constructs. And what this actually does is we started figuring out like, hey, we can, of course, abstract away some of the individual AWS services that you can create. But why don't we even take this to the next level and actually give you kind of mini architectures that you could go ahead and deploy, and where you actually kind of like, start connecting and integrating them without even having to write, for example, the Lambda code or specifying the DynamoDB table or whatsoever. So another, I think, very interesting thing that you can take a look at as well whenever you start using CDK is to, instead of, provisioning all of these individual components, why not take a look if there's maybe already a construct that does all of that stuff together, that we maintain, that we patch, that we will, provide also with documentation that makes it even faster and even easier for you to create applications, right? So take a look at some of these constructs that we have. And yeah, that's it for me. I hope you found this topic useful, and I hope that I've inspired you a little bit, at the very least, to take a look at CDK. I have a lot of, still a lot of appreciation, and I still use Amplify and SAM quite a lot. But I have to admit that, especially CDK, I think with these constructs that I just showed you, and with some of these abstraction, it's very quickly becoming my favorite deployment framework. Yeah, and I hope the same thing goes for you as well. Before we go to the Q&A, you can follow me on Twitter. I tweet mostly about serverless and kind of what's happening in that area. So if you're interested in that, take a look at that account. And also feel free to just drop me an email in case there's anything I can help you with. So maybe specifically with your project or with your company, or you maybe have any questions around, CDK or Terraform or anything else like that. Feel free to reach out as well. I'm more than happy to help out there. So thanks again, and I think we'll switch over to the Q&A now. So let me just quickly take a look if there's any questions or topics. I, of course, haven't seen the chat at all, right? So I have no idea what was happening over here. I see a couple of people were using a bit of a discussion around Amplify. Feel free to submit your questions as well, right? I'm just quickly debugging right now if there's anything that was there. So I see a question, or maybe more a comment from Jordi, for example, around integration, for example, with Amplify, right? I don't know if it's exactly trying to just make sense out of the questions, but there are what's maybe interesting to mention here. So some people might be saying, hey, I already invested in SAM or in any of the other infrastructure as code platforms. So there are a couple of ways actually that you can, for example, embed Amplify code or Amplify projects, or even serverless application model projects within your CDK stack. So from that perspective, I was kind of saying that CDK is kind of the infrastructure as code tool, maybe to rule all of them, right? Because you can basically deploy everything, and you can use it in a very flexible type of way. But there's also a couple of ways that you can, for example, import an existing Amplify or an existing SAM stack. So if you Google quickly for CDK SAM or CDK Amplify, you will probably end up with the CDK documentation that actually shows you exactly how you can do that.
Yep, give it to them.
All right, Mark, thank you very much. I don't believe there are any more questions left in the comments, so I would say this is it for now, I guess. From what's going on in our office, I see some discussion going on right there.
Yeah.
People who are watching you live here, but yeah, if there's no more questions, then just let's leave it at this. I would like to thank both you and Léon very much for inspiring us to use more of Amazon's services. We're very surely going to do a lot of experimenting with it, and we'll be sure to reach out to you if we have any questions ourselves. For everyone else watching, you can always review both of these talks on our YouTube channels and our social media channels. And I would like to conclude by asking you to follow us on social media for updates on our next Ode to the Code event, which will take place somewhere after the summer, probably. So that's it for this evening. Thank you very much. Grab a beer and enjoy AWS. Thank you.